All right, so there are two main types of numbers. There are rational numbers and irrational numbers. Rational numbers are numbers that can be written as a fraction. So it's got to have a denominator not equal to 0 because that's undefined. And the way you remember that is rationals or fractionals. So if it can be written as a fraction, it's rational. So examples, 4. 4 can be written as 4 over 1. 1/2, clearly a fraction. 0.75, 3 over 4. 0.26, any repeating decimal can be written as a fraction. The square root of 9 is rational because it's just the number 3, which is 3 over 1. And a special note here, the repeating decimals are numbers that can be written in fraction form. All right. Irrational numbers are numbers that cannot be written as a fraction. So examples of an irrational number would be the square root of 7, or the square root of 5, or pi, or e, which both of these represent numbers that are irrational. Okay, so any non-perfect square root is an irrational number. Oh, I have pi and e right here, are both used to symbolize the irrational numbers. Pi is the most used irrational number in this course. You always use pi. It's shortened and often used 3.14 instead of the symbol pi, but your calculator has the symbol. All right, so important ideas to remember when adding and multiplying rational and irrational numbers. One, don't overcomplicate this. Just try to keep it as simple as possible. So basically, we're gonna start just with adding. When you add two rational numbers, you get a rational answer. Your answer will always be a rational number. When you add an irrational number to a rational number, the answer is going to be irrational. So rational and irrational together is not rational. The only way to get a rational answer when you add two irrational numbers together is if they are inverses of each other. So one is the positive and the other is the exact same thing, but it's the negative version. So when you add those together, you get 0. So that is the only rational version. So you can say sometimes you will get a rational answer when you add a rational and an irrational, but that's only if they're inverses of each other. So, for example, rational plus rational equals rational. 3 plus 4 equals 7. 2 plus 5 equals 7. 1 plus 0 equals 1. Any version of rational plus rational is going to give you a rational answer. A rational plus an irrational. 3 plus the square root of 2. You can't even actually do anything with it, but just write it next to each other. 3 plus the square root of 2. That's irrational. An irrational plus an irrational is most often irrational. Square root of 5 plus pi. All right, so square root of 5 plus negative square root of 5, that would equal 0. But this, again, you can't even really do anything with it. Now when you're multiplying, okay, rational numbers together, you'll always get a rational. So kind of like adding. When you multiply a rational times a rational, you'll always get a rational. When you multiply a rational to an irrational, it will always be irrational. When you multiply two irrational numbers together, sometimes you're going to get rational numbers and sometimes you'll get irrational numbers, depending on what it is. So some examples. A rational times a rational. So I've got 2 times 3 halves. That equals 6 halves, which just equals 3. It's rational. Irrational times a rational number. It's just 4 times the square root of 3. You can't do anything other than just set them next to each other. So an irrational times an irrational that will give you an irrational number is pi times the square root of 3. Well, that's just pi square root of 3. Can't do anything else with it. Okay? An irrational times a irrational number that gives you a rational number would be like the square root of 2 times the square root of 2. Well, that's the square root of 4. Square root of 4 simplifies to 2. Okay? If I did square root of 2 times 1 over the square root of 2, I would end up with the square root of 2 over the square root of 2, therefore equaling 1. So there's a couple different ways. So rational times rational, always rational. Rational and irrational is always irrational. But an irrational times an irrational is sometimes it's rational, sometimes it's irrational.